right, so let's talk about the quotient rule. The quotient rule, along with the power rule, product rule, and chain rule, is another method for finding the derivative of a function in a very specific case. Now there's a proof to why this works and how this was all figured out, but this video won't go through that. What this video talks about is how to apply the quotient rule, like just how to use it to take a derivative, and when to use the quotient rule, right? What situation is this most applicable in? So you have, say you have a function, h of x, right, and the letters are arbitrary. So you have some function h of x that can be represented as a fraction where you have a function in the numerator and a function in the denominator. Typically this means a variable is both in the numerator and denominator. That's kind of important. I'll talk about that more when we do examples. So let's say you have a function represented like this. The derivative of h of x can be represented as, in the numerator you have the derivative of f of x, which is your numerator, multiplied by the original denominator, g of x, subtracted by the original numerator, f of x, multiplied by the derivative of your denominator, g of x. And then all of that is over your original denominator squared, g of x squared. Okay? So this is definitely the messiest looking of any of the other rules that I mentioned, but with enough practice, it'll be super simple. You'll be experts in this. So let's look at some practice problems. So here's our first example. Now for the first example, I'm going to kind of take my time. I'm going to go a little slower, talk more in depth about what's going on, explain step by step why I'm doing what I'm doing. And that's mostly for the purposes of really hammering home the quotient rule, making sure you guys know what's going on. Any example I do after this will be a bit quicker. So just know the first example is a bit longer just because I'm kind of really explaining every step. Now, for this particular function, we're starting off a little easy, right? A simple fraction. How do we know to use the quotient rule? So we have in our numerator, x, our variable, exists in the numerator, and we have an x also in our denominator. So that satisfies the condition of we have some function that's represented by a fraction with two unique functions in the numerator and denominator. Now, something I suggest doing in the beginning, when you're just starting out and practicing this to help you keep track of what's going on, is to kind of write this on the side, right? Keep kind of track of all your information. You don't need to do this once you get more comfortable with the quotient rule, although you might prefer to continue. So what are the necessary components in the quotient rule? Well, you need the derivative of the numerator and the original numerator, right? You need the original denominator and the derivative of that denominator. And you need the denominator squared. Okay, so you need 5 things to fully write out the quotient rule. So let's write out each thing to the side. Clearly, my numerator is going to be the first function, and I'll just name that g of x. My denominator will be my second function, and I'll call that h of x. Okay? So what do I need? Well, I need g of x, and I'm going to need g prime of x, or derivative of g of x. A lot of times I'll refer to this as just prime, rather than saying derivative of. You need h of x. You need h prime of x, and you need h of x squared. Now let's just find each one of these pieces of information. So g of x is our numerator. That's easy to do. X squared minus 2x. The derivative of g of x is easy. We're just using the power rule, right? That's going to be 2x minus 2. You should be familiar with the power rule at this point. So our h of x is our original denominator. So that's 3x minus 4. And the derivative of that is just 3. And now for our derivative squared. So that's going to be 3 of x minus 4 squared. So 3 of x minus 4 squared. And you should be comfortable with opening up this parentheses at this point. It's fairly trivial. Once you open that up, you're going to get 9x squared minus 24x plus 16. All right, now we have all the components we need to, do the quotient rule. So our quotient rule says that f prime of x should equal the derivative of the numerator, so g prime of x, multiplied by the original denominator, h of x, minus the original numerator, g of x, multiplied by the derivative of the denominator. And that's all going to be over the original denominator, not g of x, h of x squared. Now, the reason I suggest you write this out when, just starting practicing, is to keep track of all of those pieces of information. Now we're just going to substitute into our equation, right? So what is g prime of x? That's 2x minus 2. What is h of x? Right there, 3x minus 4. Now that's going to be subtracted by g of x. Right there, that's x squared minus 2x. Multiplied by h prime. Oh, forgot to put the prime there, which is 3. And all of that should be over h of x squared, which we have written down there, right? So that's 9x squared minus 24x plus 16, okay? Now, at this point, all the calculus is done. We took the quotient rule. All that's left is to just condense everything and simplify, cancel out like terms and all that, which is algebra, right? So the calculus part's over. So now let's just simplify this as much as we can. So I'm going to just multiply this out, right? You should be familiar with multiplying binomials. And at up top, we should get 6x squared, right? 2x times 3x. And then plus 2x times negative 4, which is negative 8x. And then negative 2 times positive 3x is negative 6x. And then negative 2 times negative 4 is positive 8. And that's still subtracted by the entire back half. And that's just distributing a 3, which gets us 3x squared minus 3 times 2 is 6x. And the denominator stays as 9x squared minus 24x plus 16. All right, hopefully this is making sense so far. As these final steps should be fairly simple, we're going to just distribute this negative sign. So we still have the 6x squared minus 8x minus 6x plus 8 minus 3x squared minus 6x all over that denominator. 9x squared minus 24x plus 16. Okay? Now, last step. We just have to cancel out like terms. This, forgot that when you distribute this negative, this should become a positive 6. Okay? So, easy enough. This positive 6 and this negative 6 should cancel out. This negative 3x squared and this positive 6x squared are like terms, and that's going to become a positive 3x squared. So all of this should finally equal, right, positive 3x squared minus 8x plus 8 all over our original denominator of 9x squared minus 24x plus 16. And that would end up being our final answer. That is the derivative of our original function. Now, again, quotient rule looks messy, but really it's just a few simple steps. It's figuring out what each of these 5 things are, and really 2 of them are kind of given to you. And then plugging in to your quotient rule, And lastly, doing some quick algebra to simplify your function. Hopefully that makes sense. Now let's look at another example. So here is our second example. It looks a little more complicated than the first one. And like I mentioned before, I'm going to go through this a little bit quicker than I did earlier. Now, I'm not going to write this legend on the side, right? However, I highly recommend you do that if you're still finding yourself struggling with the quotient rule, right? Like I said, it's one of the more complicated methods to use. It's definitely one of the messiest. So at this point, I suggest you pause the video and try this out yourself. I have a feeling a lot of you are not going to do that, but let's just go through this, all right? So how do we know to use the quotient rule? We have a function on top and a function on bottom, right? It's in a fraction. And we have the variable x in the numerator and in the denominator. So let's use the quotient rule to differentiate f of x. So what does the quotient rule tell us? Well, first we need the derivative of our numerator, right? So the derivative of 4x to the third minus 7x should just be 12x to the second minus 7, multiplied by the original denominator, which is 5x squared plus 2. And now subtracted by the original numerator, 4x to the third minus 7x, multiplied by the derivative of the denominator, which we can easily find is 10x. And then that's all going to be over the original denominator squared, 5x squared plus 2. Now, for exam purposes, depending on who you have as your instructor, they might make you multiply this out, they might not. I'll have this multiplied out by the end. Okay. So next, we actually start doing the multiplication. So in the numerator, we simply distribute this. And again, you should be familiar with multiplying binomials at this point. And what we're going to end up with is 60x to the fourth minus 35x to the second plus 24x to the fourth minus 14 minus, and then multiplying this out, you're just really distributing the 10x, right? You end up with 40x to the fourth, 40x to the fourth minus 70x squared. And that's all over 5x squared plus 2 squared. Right, at this point, after you've written this down, the calculus is done. Right, at a certain point, you'll be doing the calculus portion of it in just one step. Everything else I write is me just condensing and simplifying everything algebraically. Okay, so now next thing to do is to distribute this negative sign. And I have 60x to the fourth minus 35x squared plus 24x to the fourth minus 14 minus 40x to the fourth plus 70x squared. And that's all over 5x squared plus 2. All right, now in just one last step, we're going to cancel everything in the numerator out that we were able to, right? Combining like terms. Okay, so combining like terms, the 60 and the 40 x to the fourth should be able to combine to 20x to the fourth. All the x squared terms can become 35 and 70 and 24, 59x to the second plus 59x to the second. And, oh, see, that's what was messing me up. I made a slight mistake here. This should have been 24x to the second. I accidentally wrote to the fourth. next, I only have a negative 14 left. Okay? And I'm going to just distribute out this denominator. So you should be familiar with, a plus b squared should be a squared plus 2ab plus b squared, which gets us 25x to the fourth plus 20x squared plus 4. All right, so simple as that. All right, so let's move on to the next example. So here's our third example. Now, it definitely looks a little bit more complicated than the last two. I really want to stress the fact that being able to just take the derivative of your trig functions as well as your logarithmic functions like ln and exponential functions like taking the derivative of e to the 2x and stuff like that, super important, right? You're going to see a lot of examples of this, including, I guess, this one. But once you're familiar with those rules, it's just as easy as doing any other derivative problem. Now, again, if you're still having trouble, on the side, do that legend thing I had earlier. So let's take the derivative, right? F prime of x should equal the derivative of your numerator, right? Which will just be 4 cosine x multiplied by the original denominator, 2x plus cosine x, subtracted by your original numerator multiplied by the derivative of your denominator. So subtracted by 4 sine x multiplied by derivative of the denominator should just be 2 minus sine x. And then all over your denominator squared, 2x plus cosine x squared. And that whole thing should be in parentheses. All right, so again, in just one step, we finished the calculus. Now let's do the algebra. So let's multiply everything out. Okay. Let's see. Okay, so multiplying this out, we should get 8x cosine x plus 4 cosine squared x minus, and then all in parentheses because I haven't yet distributed out the negative, 8 sine x minus 4 sine x squared. Okay, distributing out the negative. Oh, I'm sorry. Denominator still your 2x plus cosine x squared. Right, distributing out the negative should get me now, my numerator is 8x cosine of x plus 4 cosine squared x minus 8 sine x minus 4 sine squared x all over 2x plus cosine x, and that whole thing is squared. Now I'm going to do a little bit of rearranging in the top portion, right? And this is why it's kind of important that you remember certain trig identities, and you'll see why in a second. Now, it's something you will if you took a pre-calculus course, I know some people haven't, some people go from Algebra 2 to calculus. If you took a pre-calculus course, it's something they definitely went over. And if you've only taken Algebra 2, it's something they should have definitely gone over. Here, I'm going to grab a little more paper just to keep doing this out. So the next line, what I'm going to rearrange it to is going to be here. I'm going to bring my cosine squared and my sine squared together. So what I'm going to have now is an 8x cosine x plus 4, plus 8 sine x, my bad, plus 8 sine x, and then that's going to be a plus 4 cosine x, cosine squared x. And then I still have the, again, I keep doing that. When I distribute this negative, this should have become positive. Plus 4 sine squared x. And that's all over the denominator that I'm continuing to have throughout. All right, now the reason I did this is I'm going to take out this common term of 4 from here, the sine and cosine squared, right? And here's why. Just 8x cosine x plus 8 sine x plus 4 times cosine squared x plus sine squared x over 2x plus cosine x. All of that squared. A trig identity you should be familiar with at this point is cosine squared plus sine squared equals 1. So I can completely just eliminate this term. All right, leaving me with the final numerator being 8x cosine x plus 8 sine x plus 4. And then I'm left with a final denominator by fully multiplying this last part out, right? Using a plus b squared should be a squared for x squared plus 2ab for x cosine of x plus b squared, which is cosine squared x. And that's your final answer. So that's why it's important to really kind of be familiar with your trig identities, right? It's what allowed me to simplify this in the first place. Otherwise, I would have been left with this numerator, with no other way to really simplify anything. All right, so hopefully that third example made sense. Let's move on to our last example. So the last example that I wanted to go through is definitely going to look a little weird, right? This is something you can do quotient rule on to find the derivative. The function is x to the 7th power over 8. Now I've specified that when you're looking to do the quotient rule, you should look to find a variable in the numerator and a variable in the denominator. You don't necessarily have that here, but you do have a fraction and you can still do quotient rule with it. However, you can convert this and use power rule with it. So let me show you both methods of doing it, and then show you why I'm really kind of specifying only do quotient rule when you have a variable in the numerator and denominator. Okay, so this can be easily converted to 1 over 8 times x to the 7th, right? And quite simply, just using power rule, you can find the derivative of f prime of x in just one step. That's going to be equal to 7 over 8 times x to the 6th power, right? However, it doesn't mean you can't also use quotient rule with it. So let's use quotient rule. So that should be the derivative of your numerator, right? So that's going to be 7x to the 6th times your original denominator times 8 subtracted by your original numerator x to the 7th minus, multiplied by the derivative of your denominator, which is 0, right? Derivative of 8 is 0, all over your denominator squared, which is going to be 64. Okay? Now, going through all the steps, I combine like terms. This should now be, I'm just going to leave this as 7x to the 6th, right, multiplied by 8 over 64 equals, and then the 8 and 64 can simplify, and you could reach 7x to the 6th all over 8. Okay, so quotient rule still works, right? You have two methods of doing this, but one is clearly easier than the other, right? And I used a very simple function. You could get something more complex where using quotient rule would take you a very long time. So there's a bit of critical thinking involved when doing really any mathematics, but especially in calculus, right? Just kind of knowing how to look at and manipulate a function will save you a lot of time on certain problems, right? You'd rather do this than do this whole thing. Okay, hopefully that made the point I was trying to make. That should be it for this video. So just a quick review: quotient rule. What you want to look for is a fraction where in your numerator you have the variable, and in the denominator you also have the variable. If so, the quotient rule says your numerator is going to be the derivative of your numerator times your denominator minus your original numerator times the derivative of your denominator all over your denominator squared. All right, and really it's going to come down to practice, right? The more you practice, the easier this gets. And eventually, you'll be an expert. All right, if there are any questions, leave it down in the comments. That should be it.